Iceland's volcanic eruptions will burn for centuries, they're a hotbed for scientific discovery, James Day from The Conversation reports. To experience a volcanic eruption is to witness nature's raw power, and if you would like to see one for yourself, Iceland is a great location for it. Since 2021, 7 eruptions have taken place along the Reykjanes Peninsula, close to Reykjavik. These recent Icelandic eruptions have garnered attention from Earth scientists like me, he says. The eruptions help us understand how volcanoes work in incredible detail. My team has been taking samples from eruptive lava from the Reykjanes Peninsula and finding some interesting results. Let's remember it's on the transatlantic trench and it's on a hot spot. There's a magma plume under there. One of our findings suggests, he says, that magma from the first eruption pooled just under the island surface, where it built up the energy to spectacularly erupt. This initial burst of volcanism made it easier for more eruptions to follow after it. Why is Iceland called the Land of Fire? The island nation of Iceland is sometimes called the Land of Ice and Fire. Early settlers witnessed several great fires or volcanic eruptions along the Reykjanes Peninsula. This is what it would look like, as you can see. This is the December 2023 eruption. Now, after about 800 years without a volcanic event on the Reykjanes Peninsula, the Fagradalsfjall volcano roared to life in March 19, 2021. Then 2 more discrete volcanic events occurred at Fagradalsfjall in 2022 and 2023. Subsequently, 4 more eruptions have taken place to the west at the Sundukur fissure system in 2023-24. And while these eruptions provide an incredible spectacle, they also have the power to wreak havoc. The recent Sundukur eruptions, threatening the fishing town of Grindavik, the geothermal power plant at Svartsengi, and Iceland's premier tourist destination, the geothermal spa, the Blue Lagoon. Lava erupted within the town limits of Grindavik, and only human-made berms have prevented further destruction. In other words, they made tunnels, chasms in order to stop the lava flowing there. And what makes Iceland so volcanically active? Iceland is a unique place on Earth. It's part of a huge chain of volcanoes submerging in the center of the Atlantic Ocean, with Iceland being exposed above the ocean surface. This volcanic chain is known as the Mid-Atlantic Ridge, and it plays an essential role in plate tectonics. Plate tectonics describes how the vast, rigid plates that make up Earth's crust slide past, into, and under one another. Their behavior slowly reshapes Earth's surface. In some locations, the plates collide to form mountain ranges like the Himalayas. In other locations, one plate slides under another, creating volcanoes and earthquakes like in Japan. On the Mid-Atlantic Ridge, which stretches between the South Atlantic and the Arctic Ocean, the plates pull apart, allowing molten magma to pour through, and this magma solidifies into volcanic crust and creates new parts of the tectonic plates. Geologists have also found a buoyant hot plume of rocky material rising from deep in the earth that intersects with the Mid-Atlantic Ridge under Iceland. This plume, along with several other similar plumes in the central and southern Atlantic, may have triggered the formation of the Atlantic Ocean basin more than 200 million years ago. The plate tectonics associated with the Mid-Atlantic Ridge and the hot rocky plume under Iceland together form Iceland's volcanoes. Scientists have been able to show that previous eruptions on the Reykjanes Peninsula are not random in time or space. Instead, they occur in periods that last centuries and along the same volcanic zones. These patterns indicate that these volcanic periods happen when vast tectonic forces pull apart the Reykjanes Peninsula. It appears that while the plates pull apart evenly, volcanism along the Reykjanes Ridge segment pulses with time. What's driving the eruption? Many groups, including my colleagues from Iceland, have been collecting the erupted lavas on a near daily basis. The collected samples provide a vital scientific time series of the eruptions. Taking a volcanic time series is like regularly drawing someone's blood to understand their medical condition. In this case, though, the blood is red hot lava. An initial study by another team in 2022 suggests that the mantle, the solid geological layer beneath the Earth's crust, was melted to feed the lavas in Iceland, and that the lava's chemical makeup was changing over time. They suggest that these changes had to do with where and when the melting was happening in the mantle. In July 2024, my search team and I published a longer time series of the lavas from the eruption using a sensitive chemical method that helps us understand the lava's composition and origin. The layer of basaltic rock that people live on in Iceland extends to the depth of about 9 miles down, that's 15 kilometers. It's part of Earth's crust. The mantle that lies directly beneath this crust is distinct. It's made mostly of minerals like olivine that form a rock called peridotite, and the magmas feeding these volcanic eruptions come from mantle peridotite. The chemical method that my team used revealed that the first magmas feeding these eruptions rose from the mantle but got stuck beneath the surface in a magma chamber for as long as a year. The rock in the chamber walls melted into the magma, and we could see traces of them in our analysis. Our research also suggested that the magmas gained water, carbon dioxide, and other gases from sitting in the magma chamber. This water and gas allowed the magma to build up enough pressure to break through the surface and erupt as lava. Magma pooling in the crust can trigger explosive eruptions. The beginning of eruptions like those in Iceland or in La Palma in the Canary Islands in 2021 may require this type of pooling. What might we expect in the future? History tells researchers that these eruptions will likely last a long time. The volcanoes will erupt periodically every few years, for days to months at a time, for up to several hundred years in the future. Generations of geologists and volcanologists are likely to forge their careers in Iceland, and millions of geotourists will get to experience the hauntingly beautiful eruptions. With all these eruptions, Icelanders will have to adapt. Lava flows can disrupt infrastructure such as the Svartseki geothermal plant, and volcanic gases can, of course, cause health problems. The Fagradalsfall and Sundunkur eruptions have already provided scientists with a treasure trove of data and insight into how volcanoes work. Continued study of volcanism on the Reykjanes Peninsula will help scientists understand how, when, and why eruptions take place, and to better manage the hazard associated with living with volcanoes. This is from The Conversation by James Day, Professor of Geoscience, University of California, San Diego, on Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.